Okay, I'd like to point out something that in the first part of this example, I don't think I explained well enough, so let me just clarify it a bit more here. So our surface for this example, again just reviewing, was the intersection of the unit sphere with z greater than or equal to 1 over square root of 2, which I'm calling alpha. So if I graphed it, it would look like this. So it's the portion of the unit sphere where the z value is alpha or greater. So it looked like this. And then we said, okay, let's parameterize it using spherical coordinates like I did over here, where the rho value is 1. So it'd be just sine phi cosine theta for x, sine phi sine theta for y, and cosine phi for z. Then I said, okay, well, we need z to be greater than or equal to alpha. Again, alpha is 1 over square root of 2. So, but z is also equal to cosine phi, so that implies then the cosine of phi is greater than alpha. Then I took cosine inverse on both sides. That's where it was kind of misleading what I wrote next. So this is what I should write. So I should have written this. So the inequality should have flipped here. You might say, well, why? You didn't multiply both sides by a minus sign or whatever. And it's because the cosine is a decreasing function. So let's look at the graph of cosine for a second. So here's a graph of cosine between 0 and pi. And recall the phi angle when you have spherical coordinates. If we want to pick up the whole sphere, it would go from 0 to pi. So I'm looking at 0 to pi here. But now we have the restriction that z is greater than or equal to alpha. So I put alpha up here on the y-axis. And alpha again is 1 over square root of 2. So then when I do inverse cosine of alpha, we showed it was pi over 4. But you can see then to the left of pi over 4, the y values are bigger than alpha. Okay, that's why I chose 0 to pi over 4. So therefore we can say then that our phi is between 0 and pi over 4. So again, if you recall how the phi angle is measured, say this is the z-axis here, but there's and this is my vector or point on the sphere, say forming a vector. The phi angle is in here, so it's the angle between the z-axis and your point on the sphere. So it's saying the angle is going to go from 0 to pi over 4. And that makes sense from the picture. So that'd be 0 to pi over 4. So that's how I got the phi being 0 to pi over 4. So in the video, I should have wrote it. I wrote this correctly in the video, but I think it was kind of misleading because I had this inequality flipped here. But when you take the inverse cosine here, actually this inequality should have flipped. Then would have made more sense. Okay, so let's leave it there. So hopefully that answers the question how I got 0 to pi over 4 in the first part of the video. Okay.